inverse functions, we need to understand the graphs of all the 6 trigonometric functions very nicely. Because unless and until we don't understand, we don't know the graphs of the trigonometric function, then it is extremely difficult for us to understand the inverse trigonometric functions. This knowledge of the graphs of 6 trigonometric functions, along with the very important theorem of invertibility, which we read earlier in the first chapter, and the statement of that theorem is that a function f, a to b is invertible if and only if f is bisective. So this bisectiveness of function will play a very important role for determining that the inverses of these 6 trigonometric functions, they actually exist, and then we will find it out that what are the possible ranges for this 6 trigonometric functions within which they are acquiring all their possible values once and only once. Because if at all we want that function should be invertible, then it ought to be bisective. So that will be the main principle which we shall be deploying for finding the existence of inverse function. And once we do it, then we will see that what are the possible domains and ranges. So we have taken 3 graphs in quite a good detail, and they were sin x function, tan x function, and one more we did cosec x function. And therein what we really noticed was that within the range minus pi by 2 to plus pi by 2, in the case of sin x, this was the closed interval. In the case of tan x, it was the open interval. In the case of cosec x, it was open on the left side, minus pi by 2 to 0, and 0 was excluded, so it was open both ways. Rather, at minus pi by 2 it was closed, sorry, at my left side it was closed, and then it was union of 0 to pi by 2, and pi by 2 it was closed. So all these things, I would like to caution all my students that studying the inverse function will not be least difficult provided you understand in the entirety these 6 functions. So since there had been a break of a good number of days before when I took my this previous lecture, all the topics of the first chapter, I have made this videos, and I have posted it also on the YouTube. So those who have missed the class, my request to them is that if you really wish, then you can go through those videos. The link, of course, today I will be sharing with you once again, and the link of all the 3 videos I will be sharing it. So now quickly coming up back here, because I don't want to rush to this inverse trigonometric function. I really wish to make it sure and doubly sure that the students, they do understand these graphs. So today I will take 2 more graphs here. One will be for cot x function, and other will be for, say, that day I took cosec x function, today I will be taking sec x function. And in between, I had been telling you the way outs, that how to remember it, because remembering all the results at one go will really be difficult, and or see, even if you have understood them in their entirety, then of course see, recollecting those results will be a cumbersome job, but then there is a way out for it. And as earlier I have said, that out of these 6 functions, 3 of them, namely sine, its inverse, that is cosec, and tan, their principal branches shall lie between minus pi by 2 to plus pi by 2, sometime open, sometime closed, sometime some element will be missing there, but broadly it is minus pi by 2 to plus pi by 2. And for the rest 3 functions, it is 0 to pi. Again see, for cos x it will be closed both ends. For cos x, for cot x, it will be open on both the ends, and for this sec x, in between the pi by 2, this element will be deleted from your this thing, because there the function won't be defined. So all these things please take care. Now today I am taking first this sec x function. Why is the graph of sec x function? First I will take graph of sec x function, though now sec x, how we have defined it. Sec x, sec theta or sec theta is defined to be 1 upon cos theta, and as I said that only sin theta and cos theta, they are the basic functions. Rest 4 are derived from them. And about cos theta, how we have defined? Cos theta we have defined to be what? Abscissa upon R1. So putting that value, what we will get? X1 upon R1, so that will go here. So 1 into R1, so this is precisely nothing but R1 upon X1. Where what is R1 and what is X1? That need to be understood. See, R1, R1 and X1, they are respectively the distance of the arbitrary point chosen on the terminal ray, and x1 will be the x coordinate, or better you call abscissa of that arbitrary point which you have chosen on the terminal ray. So with this understanding, and as we had been doing earlier, we will be taking a unit circle, and this arbitrary point on the terminal ray, we shall be choosing at the unit distance. For gaining an important advantage, that when this R1 becomes 1, then see the value of this sec theta will be depending only upon the one parameter, and that is the abscissa of that arbitrary point chosen on the terminal ray. So that will ease the working of obtaining the graph here, because see, depending on one variable is simpler, and you have also seen that in the case of tangent theta and cot theta, there see we had no way out. We had to do, we do need to depend on two parameters, and that's why see all that thing is a bit relatively bit cumbersome than obtaining the graph of the four functions, namely the sine, the cos function, and their inverses, sec and cosec. These four will be depending only on one parameter, that is tangent theta and cot theta. Their graphs will be depending on the two parameters. So with this understanding now, sec theta is equal to what? 1 upon x1. And what is this x1? I have already defined it. So now see, for what I will do, I will draw a unit circle. This is my unit circle. The coordinates of these 4 points are well known. This is 1, 0. This is minus 1, 0. This is 0, 1. And for this point, it is 0, minus 1. And then see, what we will do, we will move over this theta, and then the value of sec theta you will be finding. So initially the value will be from 0 to pi by 2, that is in the first quadrant. Then see, we would be moving it in the second quadrant, that is from pi by 2 to pi. Then in the third quadrant, 3 pi by 2, and then finally to 2 pi. So this is how we will try to obtain the graph of this thing. That is first between 0 to pi by 2 is first quadrant. Our terminal ray, we shall be moving from 0 to pi by 2. Gradually it will go towards pi by 2, and then we will see that how the value of abscissa is getting changed, and consequently how the value of 1 upon x1 will change. And remember, x1 is the coordinate, x coordinate of the point lying on the periphery of this unit circle, on the circumference of this unit circle. This is what we will always take it, because R1 we have taken to be 1. Sec theta was how much? R1 upon x1. R1, that's why purposely we are taking at a unit distance. So now please see how the things will move on. In the first quadrant, one thing is quite obvious, that see, these are my various position of the terminal ray. Initially it was 0, and then when it was 0, then what the thing was? It is absolutely 1. The value of x1 is 1. Then see, as you go a bit this thing, then the value will diminish. Then again, when you increase the value of theta, it will diminish further, it will become this much, and then this much, and then finally see, when you are exactly, when your this terminal ray is coinciding with this pi by 2, then it will be 0. So see, as you go from 0 to pi by 2, as this terminal ray goes from 0 to pi by 2, then the value of this x1, that is x abscissa, that remains positive, and it diminishes from 1 to 0, 1 to 0. And mind it, in between it will take all the intermediate values. It will take all the intermediate values from 1 to 0. So what will be its effect? And it will be remain positive. Exactly at pi by 2 it will be 0. 0, of course, to say 0, it is positive? No, it is non-negative. So throughout this first quadrant, the value will remain non-negative. Non-negative. So what will be its impact on sec theta being equal to 1 upon x1? So one thing is obvious. x1 is non-negative. So the value of 1 upon x1 will be non-negative. Non-negative, see, it is positive. Right now we can take it, because x1 we can't take 0. At pi by 2 it is undefined. At pi by 2 sec theta is undefined. So x1 will not be 0, and for rest of the things the values will be this thing positive. And what? See, initially when this theta, this terminal ray is coinciding with 0 degree line, that is, it is aligning itself with the positive x direction. 0 degree means both initial ray and the terminal ray, they are coinciding with the positive x-axis. So here the value of x1 will be 1. So exactly at 0, the value of sec theta will be how much? It will be 1. Now see, as denominator diminishes, the value will keep on increasing. Suppose it becomes 0.9. So 0.9 means what? 10 upon 9. Then 0.8. So it means what? 10 upon 8. Further value increases. So then again 0.7. So it will be what? 10 upon 7. Value is increasing. So it will keep on increasing. And then finally when you are very near to this thing, so the values, when you are approaching this pi by 2, then the value of x1 will be very, very small. Say 0.00001. So then it will become very large. Because 1 upon 0.001 means what? Suppose 1 upon point and followed by 4 zeros, 1. So it will be 1 followed by 4 zeros. The net value 1 upon x1 will be what? It will become a larger value, bigger value. So then more nearer we come to pi by 2, that is when x is exactly 0, then it will be undefined. But see, under limiting condition, that is when we are more and more nearer to x1, the values will increase further and further. So ultimately, that is to say the values will become bigger and bigger. So that is what we can fairly conclude, that when x1 is 0, the values will be heading towards plus infinity. When under limiting condition, what we can safely conclude is the concept of limit is still you have not learnt, I know, and that's why I am not using the terminology. But the idea is that when you are approaching a particular number, see, under limiting condition, what it means that, see, you cannot coincide with pi by 2. And as this x1 will never be 0, but you can come closer to 0 to any degree whatsoever you feel like. So that is the idea. So point is that the value would be heading towards plus infinity. Plus infinity. Now let's come on the other side. That is in the second quadrant. See, in the second quadrant, what will happen? One thing which I am drawing the various position of the terminal ring here again. So one thing which we can conclude here is that as soon as we are slightly in the second quadrant side from pi by 2, the values will become negative. The values will become negative. And see, initially when you are just slightly away, say the value of x1 will be what? Say it is minus 0.001. See, just like here, very close. So it will be very small number, isn't it? So, and then see, when you further go, the absolute value will increase. Absolute value will increase, but the numerical value of x1 will decrease, and decrease from where to where? From 0 to minus 1. Absolute value will increase from 0 to 1, but this numerical value will keep on decreasing and will decrease from 0 to minus 1. So what actually is happening? When we are right in the first quadrant side of pi by 2, then the values are very small, positive, and the value of 1 upon x1, that is that of sec theta, will be heading towards plus infinity. Means they will be becoming larger and larger. But when we are on the second quadrant side and we are very slightly away from pi by 2, the values will become negative and the values will be heading towards minus infinity. So pi by 2 here is a very interesting point, that is slightly on the right side, that is towards the first quadrant side, values are heading towards plus infinity, and when you are on the other side of the, that is towards the second quadrant side, the values are shifting towards minus infinity. That is to say at pi by 2, see sec pi by 2, exactly at pi by 2 the value will not be defined, but in the neighborhood. See, there is an abrupt change in the value of the function. One way it is heading towards plus infinity, other way when you are on the second quadrant side, then the values are heading towards minus infinity. And when we have such an abrupt change in the value of the function, then later on you will study such are the discontinuous points. The discontinuous point of our function, sec x. Here the function is sec theta. So that thing we will study later on. So right now I am writing here minus infinity, and then see what will happen. The value will the absolute value here, they will keep on this thing diminishing, and ultimately here value will be minus 1. So the value here will be minus 1 exactly at pi. Then see what will happen when you come in the third quadrant side. Again the same picture, the value of x1 will be negative throughout. So the value of sec theta will be negative, and the value will increase this time, and increase from where to where? See, at pi it was minus 1, then here see it will be say something this much, minus 0.9, say it is minus 0.89, and then see like this thing, so it is this much, and ultimately see it will be heading towards 0. So one thing is that throughout the third quadrant, what we are noticing is, third quadrant is when we are, our terminal ray is moving from pi to 3 pi by 2, 180 to degree to 270 this degrees. That is, so the value of sec theta will be negative, one thing we have seen. So value of sec theta is what, negative. So what we can do? We can consider the absolute value 1 upon mod x1 and then we can incorporate this thing. Let us see how the value of this 1 upon mod x1 are changing in the third quadrant. So as I said, initially x1 is 1. So this encircled portion will get, first we are calculating only this encircled portion value. So initially it will be 1 at pi. So I am writing here pi to 3 pi by 2. So what is happening? Exactly at pi, it is how much? 1. This encircled portion. This is negative sign. Its effect we would be taking later on. First let us concentrate only on this encircled portion. Then what will happen? This x1 will diminish. Say it is 0.9. So what will happen? When the value is diminishing in the denominator, the value will increase, and then it will further diminish. Say it has become 0.7. 0.7 means what? 10 upon 7. Then it becomes say 0.6. So 10 upon 6, further increasing. Then say likewise, see when you are very close here 0, then the value will be say 0.1. So 0.1 is what? 10. Then 0.01, so it is 100. Then say it is coming further closer to 0. So the value of x1, absolute value of this thing, x1, that is abscissa of the point, arbitrary point chosen on the terminal, that is will become further smaller. Say 0.00, say 100.01. You are still not coinciding with 0. You can come nearer to 0 to any degree whatsoever you feel like. This is the concept of limit. So the value will be 1 followed by this thing 100 zeros. So the more nearer you are approaching to this number, this 3 pi by 2, this value of abscissa, absolute value of abscissa will be heading towards 0. So the value will be getting towards infinity. So ultimately when you are going from pi to 3 by 2, the value will be getting from 1 to infinity, and as such, now if you take into cognizance the impact of this negative sign also, so you can safely conclude that the value would be going increasing, decreasing from -1 to minus infinity. And this is what you write here, -1 to minus infinity. And then see again at 3 pi by 2, see sin 3 by this thing, cos 3 pi by 2, again undefined. And see here when you are in the fourth quadrant side, this x1 will become positive. This x1 will become positive. So here see for the fourth quadrant, see this -1 upon mod x1 we have defined sin theta only for the third quadrant. For the fourth quadrant, see you can write 1 upon x1. x1 will be positive throughout. So initially it will be very small means very large positive values. And then see as you further go toward this 2 pi, so the value will further increase, the denominator will increase. The increasing of denominator here simply implies that the values will diminish, and so you will be getting from infinity to how much? Here it will be exactly 1, so 1. At 2 pi the value will be 1, and this will be the complete circle, rest all will be the repetition. Because once again you go beyond 2 pi, you will be in the first quadrant, and in the first quadrant you will get the same sort of values which you acquired in the first quadrant. So that's why this is a repetition after 2 pi. So these are the possible values which we have got. So what you are finding that in the first the values will be heading from 1 to infinity. At pi by 2 there will be abrupt change in the value. Pi by 2 the value of sec theta will not be defined. So and then see when you are on the second quadrant side, immediately the values are heading towards minus infinity. And then see they will be further increasing and increasing to -1. And then see they will be going from -1 to minus infinity. -1 to they will be further reducing. And then see again at 3 pi by 2 there will be an abrupt change in the value of the function, and it will remain positive and will go from infinity to 1. Now see, we will draw the graph of this thing. We will draw the graph of now sec theta, because we have now this thing acquired the various values in different coordinates. So I will tell you now, see, as I have been telling you time and then, that what you need to do for obtaining these graphs. See, you need to draw vertical lines at the spacing of pi by 2. At the spacing of pi by 2. See, today I am purposely not proceeding further for the simple reason that you should be well versed in obtaining the graphs of all the 6 trigonometric functions. Then only see you can understand all these principal branches and how these inverse functions they will exist, and they exist then in what interval, and so on and so forth. So this is one thing here. So I have drawn various vertical lines at the spacing of pi by 2. Somewhere in the middle I am taking 0 here. This is pi by 2, pi by 2. This is pi. This is 3 pi by 2, and then 2 pi, and then see 2 pi plus pi by 2, 5 pi by 2, and so on and so forth. Here it will be minus pi by 2, so minus pi by 2, this is minus pi, this is minus 3 pi by 2, and this is minus 2 pi, and so on and so forth, minus 5 pi by 2, and so on. Then you draw two lines here, say one is corresponding to plus 1, other is corresponding to minus 1 here. So it is minus 1, it is plus 1. This much of thing we will do. Now, see, whatever says, 0 to pi by 2, values are 1 from infinity. So 1 to infinity, please see where it is. 1 to infinity, pi by 2 it is infinity. Now see, I tell you the way out. See, we will see that all these things will automatically fit in. Provided, see, we do remember one thing. What that thing is, I repeat. I have told you that for the three functions, namely sine theta, its inverse, cosec theta and tangent theta, the principal branch is minus pi by 2 to plus pi by 2. And for rest of the three, it is 0 to pi. Now, what you need to do in the case of this sec theta and cosec theta, just for the sake of remembrance, what you need to do is that you draw a upward parabola in the principal branch other than what has been specified for this one. Sec theta branch is 0 to pi. So you draw an upward vertical parabola in the other branch, that is minus pi by 2 to plus pi by 2. So I am drawing here CPC, and the parabola will be like this thing, because see, it will be beyond this thing, like this you draw it. And then see, alternatively you draw like this thing, upwards, downwards, and you will see that it will be exactly the curve of, and here also on the inner side, do the same thing like this. And this will be the curve of cosec theta. Now let us match it. First between 0 to 2 pi, let us match it, and then see, you will find it out. See what is happening from 0 to pi by 2. The values are going from 1 to infinity. So exactly at 0, what is the value? 1. 0 to pi by 2. Please see this interval. 0 to pi by 2. Values are going from 1 to infinity. Please see. The values are going from 1 to infinity, and this is what we demand. And then from pi by 2 to pi by 2 to pi, where the values are going. See, at pi by 2 exactly, on the other side it is going 1 infinity, on this side it is going minus infinity. And pi by 2 to pi, the values will increase from where to where? Minus infinity to minus 1. Please see, minus infinity to minus 1. And then see what happens, pi to 3 by 2, minus 1 to minus infinity. Minus, see, again see, pi to 3 pi by 2, this interval. Values are going from minus 1 to minus infinity. Again see at 3 pi by 2, there will be average change in the value of the function. Here see plus infinity, because here you are having infinity to 1, and this is what you are getting here. This much of branch. This much of branch. So see, what I intend to show you was that whatever this analysis which you derived by obtaining the values of 1 upon x1 in different coordinates, see that exactly fitting, provided you do this particular exercise. Remember, the value of sin theta and cos theta, they are always embedded between -1 and +1 in the closed interval -1 and +1. Whereas the value of sec theta and that of cosec theta, they will be always beyond this closed interval -1 and +1. They will be either above this interval, means 1 to infinity, or from -infinity to -1. So this is the graph of y is equal to sec theta. Y is equal to sec theta. So this all of you will draw it, and you will convince yourself that this is the graph. Now see what we are finding it. See, once you get perfection in the graph of this sec theta and cosec theta, then see what you need to see is that we will see that what are the possible values. Of course, see the possible values are from -1 closed interval to -infinity open union. Then what? Yes, this thing 1 to infinity open. This is the values being obtained by sec theta. Or in other words, it is r minus -1 to +1. Because the values of this thing, sin theta and cos theta, they lie between closed interval -1 to +1. So here see, you subtract this thing from the real, right? So for cosec theta and sec theta, this is the range. This thing you can write alternatively like this. Okay, now see what more important thing is. Let us see what are the principal branch. I have been advocating the sec theta 0 to pi. 0 to pi, please see 0 to pi. This much of thing, 0 to pi. Here see, as you go from 0 to pi by 2, see what is more important is that see, let us see, as you go from 0 to pi by 2, the values will be from where to 1? 1. Of course, see 0 this thing, pi by 2 we will enclose. So the values will go from 1 to where? 1 to infinity. Please mind it. 1 to infinity. Open here. And then see, when you go from pi by 2 to pi, when you go from pi by 2 to pi, then pi by 2 to pi. This is closed, this is open. Then the values will go from where? See, here it is infinity. See, pi by 2, here, the right side, it is -infinity. Please see, on the other side, pi by 2 to pi when you are going. So pi by 2 you are approaching from this side, pi side, second coordinate side. Then the values are having abrupt change in the value of the function. So pi by 2 it will be -infinity to pi. At pi what it is? -1. So this is open, this is closed. This, please see, after plotting the graph, this result will be of prime importance. This shows that what is the principal branch? Principal branch of sec theta, what it is? It is -0 to pi, open interval, and from it, see, you would be excluding the point pi by 2. So this is the principal branch of sec theta. Please remember. And not only you will remember the principal branch, because understanding this thing is very easy. What is more important is that you need to understand this particular thing. That as the values from 0 to pi by 2 increases for sec theta, then that as theta increases from 0 to pi by 2, the values will increase from 1 to infinity. And from pi by 2 to pi, the value will become negative, and then these will be from -infinity to -1. See, this result, please remember this result. These two results, please do write it in your copies. See, this will be very important. This particular result, this is principal branch, okay, you can very easily mug it up, because I have told you that out of the 6 functions, 3 functions have got branches, principal branches between 0 to pi. Of course, see, sometimes close, sometimes open, sometimes open, and one point like here, pi by 2 is missing. In the case of cosec theta, the principal branch will be minus pi by 2 to plus pi by 2, and 0 will be excluded therein. 0 will be excluded therein. So, in sin theta, as I said earlier, it will be closed interval minus pi by 2 to plus pi by 2. For tangent theta, it will be open interval minus pi by 2 to pi by 2, and the principal branches is there. All these things I will give you, be telling. But more important than just mugging up the principal branches is because remembering principal branches by this particular way, that 3 of them are having 0 to pi by 2 and 0 to pi, and the remaining 3 minus pi by 2 to pi by 2 is easy to remember. But see, what is more important is this particular result. This particular result. For sec theta, this result, and for cosec theta. See, what the thing will be, I will write here, and see, I wish that that day we view the curve of this cosec theta. And there you see a parallel result we have obtained it, and that result we will be again writing here. And so principal branch, so this is for sec theta. Please remember, you do write it also. This is for sec theta. And for cosec theta, I am summarizing the result because this thing, principal branch, no doubt, it will be from minus pi by 2 to pi by 2. This will be the principal branch here, and of course, see, 0 will be the point. And you can make it out. Cosec theta is 1 upon sin theta. Sin theta becomes 0 when theta is k pi. K pi is there, here, in this branch. So, this will be the principal branch of cosec theta. But then interestingly, what will happen? Now, here see, things are simpler. As you go from minus pi by 2 to 0, and then you would be going to pi by 2, and do remember that at minus pi by 2, the value will be minus infinity, then it will be going towards, as you go from 0, it will be heading towards sin minus pi by 2 is minus 1. Okay, see, it will be minus 1, and you would be going towards then minus infinity. And here you will be going towards infinity to plus 1. See, this is what you need to remember it. And see, this is for cosec theta. These two results, please do write it. I will be giving you a summary later on. But then see, remember it. And this thing you can verify also by the same way, because we have already noticed that trick involved therein, that how you will obtain this thing, the graph of this thing, very simple. Once again I will do it because these two curves, see, if you will not perfect it, then they will keep on posing problems for you. Same thing for cosec theta, the technique is the same thing. Draw vertical lines. Draw vertical lines at the spacing of pi by 2. Like this. And then somewhere let this be 0, then a line plus 1 over here, minus 1, and a line corresponding to plus 1. Oh, now see, that day we have analyzed it and we have seen it. Principal branch is minus pi by 2 to plus pi by 2. So this is the mark corresponding to, say, minus pi by 2. Minus pi by 2, this is minus pi, this is minus 3 pi by 2. This is minus 2 pi. This is what? Pi by 2. And this is pi, this is 3 pi by 2. This is 2 pi. And this is 5 pi by 2, and so on and so forth. These vertical lines are the spacing of this thing. Now, what will be the trick is? Firstly, you draw it, and then I will show you that you will get the same this thing. Principal branch is what? minus pi. So first upward parabola is to be drawn in the other branch, that is 0 to pi. 0 to pi, first upward parabola. Please see like this. And then you draw alternatively upward and downwards parabola like this. And here, negative side. Like this. So this is the curve of y is equal to cosec theta. And see, don't just use this direct method. This ultimately, after analyzing the thing, you have drawn this thing. So what is it now? You will find that minus pi by 2 to plus pi by 2. All possible. This is the principal branch here. Please see. Between minus pi by 2 to now this thing, what is happening? Minus pi, the value is minus 1. As you are going towards 0, the values are heading towards minus infinity. And this is what you are writing, minus 1 to minus infinity. And just see. Interestingly, at 0 point here, when you are slightly on this thing, because this is the point 0 where the functional value is not defined, and this is a discontinuous point for the simple reason that the value therein, see, the function itself is not defined. But then see, in the neighborhood of this thing, when you are going on the other side, then see the value are heading from plus infinity to 1. Plus infinity to 1. See, this is what you need to. And this is the principal branch, because all possible values. Principal branch is what? Principal branch is that branch where a given function acquires all its possible value one and only once. One and only once. So this is what is meant by principal branch. And the rest are the secondary branches. It is not like that. If the cosec theta, it is minus pi by 2 to plus pi by 2. So from pi by 2 to 3 pi by 2 if you take this thing. See, this is another secondary branch, because here also all possible values are being taken. See, pi by 2 to pi, 1 to infinity, and pi, at pi of course it won't be defined, but as you go from pi to 3 pi by 2, then see what is happening, minus infinity to minus 1. So this is another secondary branch, pi by 2 to 3 pi by 2, likewise 3 pi by 2 to this thing, 5 pi by 2, again a secondary branch. Here you can have minus pi by 2 to minus 3 pi by 2. See, you can verify it. So there will be good number of branches where all these possible values are being acquired and acquired once. But see, convention demands that we will be taking our one standard value, that will be principal branch. And remember that when we are deriving the properties later on, the properties of the inverse function, then we had to ensure that we don't jump out of the principal branch. And where see that need be, then we will again try to come back in our principal branches, and that coming back into the principal branch will do some sort of manipulation where the value of the function is also not changing and we remain confined to this thing. So that is what will be the challenge for understanding the properties of inverse functions. But mind it, once again I am repeating it, that please understand the graphs of all these functions very nicely. I will not proceed further. And not only this thing that you will mug up the principal branches, this particular analysis, in the case of cos c, you 0 to pi by 2, pi by 2 to pi, how the values will be changing. That is more important. So with this thing, I take up one more here function. This time cot function I will be taking so that, but see, this is more difficult. Cot and tan are easy. They do depend upon the two parameters, both on x coordinate and y coordinate, but still, remembering their graphs, they come out, in a particular manner. So either they will be increasing all the way, or they will be decreasing all the way, and that's the reason that remembering them is a easy business. So here I am not proceeding further here with the hope and expectation that all these 6 trigonometric curves, because the rest of the analysis will be too simple, provided you can understand it. Because from these 6 graphs, see, if you can understand what is the principal branch, then of course see, you found that invertibility theorem, that a function is having its inverse provided it is bisective. So that thing will be there. So now here, without taking much time, I am straight away coming to the graph of this thing, y is equal to cot x. Y is equal to cot x. So cot x, or say better right, cot theta. So it is cot theta is what? Cos theta upon sin theta. It is again a derived function. Only sin theta and cos theta are basic functions. So it is cos theta is what? X1 upon R1, and this is what? Y1 upon R1. So ultimately it becomes X1 upon Y1. Okay. So cot theta is X1 upon Y1. So same thing we would be doing. Same thing we would be doing. First of all, we will try to obtain the curve of cot theta in various coordinates. In various coordinates. So let us do this exercise here. This is my, as usual, this would be my unit circle, and the arbitrary point I will be always taking here on the periphery of this unit circle. As usual, this has got coordinates 1, 0, this has got minus 1, 0, this has got 0, minus 1, this is 0 and plus 1. Okay. Once again I repeat it. We discussed about the beauty of coordinate system, and we explained you in detail that if there is a fraction and fraction has got this thing, numerator upon denominator. If you want to increase the value of fraction, then what you can do, you increase the value of numerator, provided both of them are positive, or you decrease the value of denominator. Now see, this is the out. If you want to decrease the value of this fraction, again two options. Reduce the value, decrease the value of numerator, increase the value of denominator. So these are the two possible ways which are available to you for increasing or decreasing the value of fraction, provided both of them are positive. Okay. Now see, nowhere. Now see, if both of them are increasing simultaneously or decreasing simultaneously, then what we can say whether the value of the function will increase or decrease. Difficult to say at the outset. But then see, then we had to find it out that suppose both of them are increasing, then we had to look in whether the increase in the value of numerator is more dominant in comparison to the increase in the value of denominator. If it is so, then the value will increase. If it is not the other way around, then the value will decrease. Likewise, see, both the values are diminishing, decreasing. Then again we have to see which of them are dominant as far as this reduction rate is concerned. If denominator is reducing more faster than numerator, then the value will, if it is reducing then this thing, then it will increase. If numerator is increasing at a faster rate than denominator, reducing at a faster rate than rate of denominator, decrement of denominator, then the value will decrease. So why I was saying that why this quadrant is very beautiful, because see, why it's such a beautiful, that see, when you go from first quadrant to second to third to fourth, nowhere you will encounter a situation where both numerator and denominator either are simultaneously increasing or are simultaneously decreasing. And that's why they are beautiful, because see, everywhere, either if numerator is increasing, then denominator will be reducing. If numerator is reducing, then denominator will be increasing. And that's why that making whether the value of this fraction will increase or decrease is an easier thing to forecast. And this is why we have been saying that our coordinates is too beautiful. Okay, with this understanding, let us see what happens. We will do this thing, theta, and then we will be writing cos theta. So theta as usual, 0 to pi by 2 to pi to 3 pi by 2 to 2 pi. And then we will find the value of this cos theta. Okay, in the first quadrant, let us see. Okay, these are the various positions. So now see what is happening here. Let us also write. Yes, I will write over here for the first quadrant. Cot theta, what it is? X1 upon y1. So initially at 0, what is the thing? Value of x1 is 1. That of y1 is 0. So means it is undefined. Cot theta is undefined, and it is undefined, but still we will say that it is infinity. Now it could be plus infinity, minus infinity. We will see on other side what it is fetching. Because one thing is sure, that throughout the first quadrant, both x coordinate and y coordinate are positive. So if we are approaching 0 from this thing, then of course we can take the value to be almost heading towards plus infinity. That way we are justified. But if from this side we are taking, again see what will happen. One value will be positive, other will be negative. So here it will be giving minus infinity. Okay. So that we will see when we will doing the analysis for the fourth quadrant. Now yes. So now what happens? You have gone for these. So what will happen when this thing is? So what this thing will give you? Now x1 has reduced, y1 has increased. Y1 has increased. So increasing of denominator means what? Reducing the value. Decreasing in value of numerator means what? Again decreasing the value of numerator. So the net result would be, and both of them are positive. So the value will be diminishing. And then further suppose you have come here, then the value is now further reduced. Numerator, the value of numerator has further reduced, and that of numerator has increased. Denominator has increased. Numerator decreasing from 1 to this much now. Then further it will decrease. So numerator is continuously decreasing, though it will remain positive, and y1 will continuously increase. So increasing the denominator means increasing the value of fraction. And this thing, x1 reducing. See, this is reducing. y1 is increasing. Increasing means reducing the value of fraction, and numerator is also reducing the value of fraction because it is diminishing. Positive, both of them are positive. So net result will be to reduce the value, and then where it will reduce. Exactly here x1 will be 0. So it will 0 and y1 will be 1. So 0 1 1 is what? 0. So what the value will be? They will come down from infinity to 0. Infinity to 0. This is what is happening. And then say pi by 2 to pi. Let us see what the thing is here. So see, just because of this beautiful coordinate system, we are finding calculation of the value of cot theta to be much easier, despite the fact that here the value of cot theta is depending on 2 parameters, whereas in the earlier case the value was depending only in rest of all the 4 cases trigonometric function, that is to say the value was depending only on one parameter, either on x coordinate or y coordinate. So but still see, calculation is simpler. In second quadrant what will happen? See, again, x1 upon y1. So for second quadrant, what we need to do is, see, first we will take into cognizance only the absolute value. Here, x1 will become negative. Please see, x1 will become negative. Minus this, ultimately it will become minus 1. Whereas y1 will be positive. So let us take this thing, x1, modulus value. First let us take this thing and we will put a negative sign here. That is to say the value of cot theta in the second quadrant will throw out negative. And then let us see, we will first consider this encircled portion, that is y1 upon mod x1. This we have defined purposely for the second quadrant, and then we will take this negative sign into we will effect of this negative sign also we will take later on. So first let us see y1 upon mod x1 how it changes. So yes, please see y1 will keep on, initially it was 1, then it will be this one, then further reduce, ultimately 0. So numerator here in this circle portion, it is reducing from 1 to 0. So numerator is decreasing. So numerator decreasing means value of fraction will reduce, and x1, mod x1. See, x1 will be negative throughout, and that's why we are taking the absolute value of x1. So that absolute value is what we are taking in this circle portion. So x1 here will increase, mod x1. It is 0 here, then this my 0.1, 0.2, 0.3, 0.4, and then ultimately it will be 1. Absolute value of x1 will be 1. So what is you are finding? That denominator is increasing. Mod x1 is increasing from 0 to 1. Increasing of denominator means further reducing the value of denominator. So both this numerator and denominator are trying to diminish the value of denominator. And mind it, when you are slightly on the second quadrant side, then see x1, this mod x1 will be very, very small, 0.00001. So this will be something very large, because y1 will be approximately equal to 1, and it will be 0.00000, say 1001. So it will be, see, heading towards 1 followed by 1000. So very large. So what effect of this thing will be that it will go from infinity to where? Ultimately y1 is 0. So 0. Now see, this is the value of encircled portion. If we take minus sign into cognizance, then the value will be going from minus infinity to 0. Sorry, as you go from here, pi by 2. See, what the thing will be at the cot theta, yes, it will be what? Y1 will be how much? Here at pi by 2, it will be 1. X1 will be what? 0. 1 upon 0. Can't say. So ultimately, see, it will be what? X1 is 0. So infinity, heading towards infinity. Okay. So minus infinity to 0. Pi, it will be 0. I think this first analysis I look into, will it be infinity to 0? 0, what it is? Y1 is 0. Please see, y1 is 0, x1 is 1. So 0. At pi by 2, y1 is 1. 0 upon x1 cot theta cos.
So
oh yes, we have written it wrong.
Yes.
We have written it wrong. It should be x1 upon y1. That's right. Because cot theta is what? Cos theta, it is x1 upon y1. That's why we were getting some faulty results. Okay, we will revisit it. No issues. Okay, I will do it once again. Here, please see. Okay, I will review it. Okay. In the first scene, what will happen? X1 will be 1, Y1 will be, see, for the first quadrant, both of them are positive. X1 and Y1, both of them are positive. So here, cot theta is what? X1 upon Y1. Yes, fine with it. So, see, if you are proceeding correct manner, you can identify your mistake, no issues. So x1 here, see, now here, at 0, what the thing is, at 0, x1 is your 1, y1 is 0. So now see, it will go from infinity to 0. Pi by 2, what the thing is, x1 will be 0 and y1 will be 1. So 0 upon 1 is 0. So values will keep on decreasing, and decrease from where to where? From infinity to 0. And this thing you can see how. Because x1 initially is what? 1. Please see. x1 is 1, y1 is 0. So 1 upon 0, infinity. Now it could be plus infinity, minus infinity. But then since we are in the first quadrant, so both values are positive. So we will take it plus infinity under the limiting condition, because this thing we are in the first quadrant side. So it will be infinity. At 0 it will be infinity. Then what will happen? Now y1 is this much. y1 has increased. See, y1 denominator is increasing. Constantly denominator is increasing. Now this much, and ultimately it will become 1. See, constantly, see, denominator is increasing. Denominator is increasing means what? The values are diminishing. the values of cot theta are diminishing. Now let us see what about x1. Diminishing means x1 should also reduce, and this is actually what is happening. Initially x1 is 1, then here for this terminal it will be this thing, for this terminal it will further reduce, and ultimately it will become 0. So see, what I was saying is that numerator is also decreasing from where to where? From 1 to 0. Decreasing denominator means reducing the value of fraction. Increasing the value of numerator, reducing the value of fraction. So both of them are trying to reduce the value of the fraction. Initially it is infinity, no doubt about it, for the simple reason that what is the thing? Here x1 is what? x1 is 1, y1 is 0, here at exactly 0. So 1 upon 0, that is either plus infinity or minus infinity. But as I said that you are approaching this thing from the first quadrant side, therefore you are justified in taking towards the value towards plus infinity. So 0 to pi by 2, it will be infinity to 0. And then let us see pi by 2 to pi 2. As I said, here throughout, this is how we will be doing it. This encircled portion will be fetching you the absolute value for the simple reason that see here x1 here will be negative, so we are taking the absolute value here, and y1 will be positive throughout, so no issues. So y1 see it is reducing from what? 1 to 0. So 1 to 0, denominator is diminishing. So the values will be increasing. Well, denominator you are reducing, so value will increase. Okay. Let us see mod x1 increasing. See x1 here it is this thing, and ultimately it becomes 1. So mod value of x1 is also increasing. So increasing means value will keep on increasing. So at here what the value will be? Here x1 will be 1, y1 will be what? 0. So this encircled portion, that is mod x1 upon y1, this value will move from where to where as you move from pi by 2 to pi. So this value at pi by 2, see slightly here, so it is 0 here, but here it will go from 0 to infinity. But then see, as I said, the value in the second quadrant for cot theta will be negative throughout, and as such what will happen? Let us take now, so here the encircling portion is giving you the absolute value. Now let us take into cognizance the effect of this negative sign. So what will happen? 0, this entire range 0 to infinity will get multiplied, and you will get 0 to minus infinity. 0 to minus infinity means what? The values are reducing. The values are decreasing. So you write it is decreasing from 0 to minus infinity. And then see, in the third quadrant, what the situation will be? Both of them will be negative, both x and y will be negative. So, for third quadrant, we can safely define cot theta to be what? Cot theta to be mod of y1 mod of x1, again I will do the same mistake, upon mod of y1. Because minus will cancel with each other. Because minus x1 will be negative, y1 will be negative, this negative will cancel, and we will let us take the absolute value. So for third quadrant, we are justifying defining cot theta to be mod x1 upon mod y1. So what is happening here? Mod x1 will reduce. So numerator is reducing from where to where? From 1 to 0. So that is to say the value of cot theta will decrease. Numerator is reducing. Means value of cot theta is decreasing. Y is absolute value of y1 increasing means denominator increasing means reducing the value of fraction, and as such both the parameters, both numerator and denominator, are working towards reducing the value of the fraction. So what the thing will be here? Initially at pi, the value are from where to where? X1 is 0. So, here we are in the third quadrant. See, here what is x1? X1 is minus 1. X1 is minus 1. And what about absolute value? X1, mod x1 is 1. And y1 is what? 0. 1 upon 0, infinity. So, infinity, let us take. And then see what will happen. The value of x1 will reduce, increase, y1 increase, and ultimately see what will happen. Y1 will be how much? 1. Mod y1 will be. And mod x1 is how much? Mod x1 here is 0. So infinity to 0. So as we go in the third quadrant, the value will be positive throughout. Though the individual value of x1 and y1 are negative, and so they will be cancelling each other in the third quadrant, and as such the value in the third quadrant of cot theta will be what? Positive. And then at exactly when you are on this side, that is on the third quadrant side, see there will be an abrupt change in the value of the function. It will be heading towards infinity. And whereas if you are approaching it on the second side, they are heading towards minus infinity. But anyway, in the third quadrant the value will be positive and they will be decreasing from infinity to 0. Now let us see when we go in the fourth quadrant again. Again this is simpler. In fourth quadrant throughout the value will be negative for the obvious reason that x1 will be positive and y1 will be negative throughout. So what we will do the same thing for fourth quadrant now cot theta. We will be defining like this, how it will be negative throughout, but then x1 is what? Positive. So you keep it like this and mod of y1. And then see, first calculate the value of this encircle quotient. That is absolute value of cot theta in the fourth quadrant we will calculate, and later on we will take the impact of this negative sign throughout. So this is what we are going to do. So let us see x1. Very simple. Now I think you people must not have understood the concept behind it. x1 will what? It will increase. Increase from where to where? From 0 to 1. So numerator is trying to increase the value of the function. This is the encircle quotient. Where we are deliberately considering the absolute values here. So x1 numerator is increasing from 0 to 1. Denominator decreasing from 1 to 0. So denominator diminishing means increasing the value. Numerator increasing, it means increasing the value of the fraction. Both are trying to increase the value of the fraction. And so it will continuously increase. And it will increase from where to where? Ultimately at x1 will be 1, y1 will be 0. So it will go towards 0 to infinity. Please see, 0 to infinity will go what? x1 upon mod y1. This value, mod of y1. In the fourth quadrant, it will go from 0 to infinity, but when you take into minus sign into cognizance, then it will go from 0 to minus infinity. And this will give you the entire analysis of this cot theta in all the four quadrants. And now with this thing, we will draw the graph of this cot theta, and we will see that how it is obtained. Again, see, same thing. What you will need to do, draw vertical lines here at the spacing of pi by 2. And then see, one sum midway 0, this is pi by 2, pi, 3 pi by 2, mark, then mark 2 pi, and then 5 pi by 2 here on the left side, it is minus pi by 2, minus pi, minus 3 pi by 2, minus 2 pi and so on, minus 2 pi and so on. Now see, this thing, what do you do with the free hand? What do? You first see, what is the principal branch of cot theta? I said, it is 0 to pi. 0 to pi. So what you need to do, simply with a free hand, just draw like this thing. This is the principal branch. And see, it is matching it. Initially 0, value of infinity, then reducing to 0, 0 to pi by 2, 0, and then 0 to minus pi by 2. This much between 0 and pi, this is the situation. And then see, rest all will be the repetition. See, rest all will be the repetition. With the free hand, you keep on drawing, see at the placing of pi, like this thing. This thing. This will be the entire curve of cot theta. And like this. Rest all will be the repetition. So this is pi. So 0 to pi, all possible values from infinity to minus infinity you are obtaining. So this is how the graph of cot theta is being obtained. Now here see, remember, what is the principal branch? Principal branch, again I said that you have to remember very nicely. Now see, for all the 6 functions, we will be writing these principal branches, and that thing, see, you will have one day in between. Please make sure that you practice all these graphs, reason them out the way I have done it, and then make sure that these principal branches are very well remembered by you. So now what I am writing here, I will be first writing here this domain and principal branches. Domain and principal branches of trigonometric function. Now see, sine theta. So here I will write domain, here I will write function, and domain, and what else? Then the functional values of this thing. So function here is sine theta. Sine theta, what is its domain? Domain is what? Sine theta, entire real line. And possible values for this range set, range you can write, so it is minus 1 to plus 1. And then cos theta, again same thing, range minus 1 to plus 1, same. And for tangent theta, it is what? For tangent theta, see, it is r minus what? You will be skipping all the odd multiples of pi by 2 from the real line to a sine theta or cos theta. Cos theta is not defined whether you have odd multiple of pi by 2. And what is the range here? R, or you can write minus infinity to plus infinity. And similarly for cot theta, see, what will be the domain? Yes, r minus k pi. This time this is r. For then cosec theta, what is this thing? It is 1 upon sine theta. So r minus what? Sine theta is 0 at k pi. So r minus this thing k pi. And what are the values here? Minus infinity to 1, union minus 1 to infinity. And then this, what is the other one? Sec theta. Sec theta is cos theta, so r minus 2k plus 1 pi by 2, and then this is will be same. But see, this is one thing. But then see, most important thing will be the principal branch. Principal branch, that you really need to understand. That you had to understand. Now, principal branch of sine theta is what? Closed interval minus pi by 2 to plus pi by 2. See, this thing should be very well remembered by all of you. But of this thing, it will be from the closed interval 0 to pi. What it is for tangent theta? It is minus pi by 2 to plus pi by 2. Open both sides. What is this thing? Tangent theta, cot theta, yes, it is 0 to pi. 0 to pi. And for cot theta, cosec theta, yes. Cosec theta, what is the principal branch? It is C minus pi by 2 to pi by 2. Okay, and from it you will, this thing, ignore 0. And for sec theta, it will be 0 to pi, and from there you will ignore pi by 2. See, principal branches you will remember. And then see, apart from this thing, What is more important is that you should know how the values are changing. How the values are changing. See, this much of thing is okay. But then see, more important will be that how the nature of curve is changing. Like here, see, I don't have, I have written somewhat like this thing. In here, see, minus pi by 2 to plus pi by 2. The values will go from where to where? As you go from pi by 2, see, I will write below this thing. Oh, okay, just understand the nature of curve. Nature of curve. Now, this is a good thing. Where, see, this thing will not help you that much. I will, see, let me write over here, because this is a very important thing, and this thing you will remember it. Because unless you don't remember this thing, see, should I rub it? I will be sending you the video of it also, but those who want to jot it down, please jot it down, because see, an interesting result I am telling you. See, sine theta, principal branches from minus pi by 2 to pi by 2. Okay. See, I am writing deliberately like this thing, a closed interval. Now, what is the nature? Here is simple. As you go, some value will continuously increase from minus 1 to plus 1. Throughout it will be increasing. If you look at the curve of sine theta, what you will find, as you go from minus pi by 2 to pi by 2, the value will keep on increasing from minus 1 to plus 1. Cos theta, you go from 0 to pi. 0 to pi by 2 you go, and then suppose union pi by 2 to pi, suppose. I am writing it in two parts especially. Now what the thing will be, as you go from 0 to pi by 2, the value of cos theta, if you look in, it will go from 1 to 0. 1 to 0. And here see what the thing will be. It will, you go pi 2 to pi, it will go from 0 to minus 1. 0 to minus 1. This is for cos theta. Please see, this is for cos theta. This is for sin theta. See, nature of curve, that will pay you a lot in understanding this properties of the inverse function. For tangent theta, see, I am writing separately here. For tangent theta, what the thing will be? As you go from this thing, minus pi by 2 to pi by 2, open loop. Then see, the value will be going from minus infinity towards plus infinity, continuously. For cot theta, see, just amount of space, this thing, cot theta. Cot theta, as you go from 0 to pi, the value will go from infinity to minus infinity. Infinity to 0, in between, okay, you put 0 to pi by 2 and then to pi. So infinity to 0, 0 to minus pi. This is what cot theta. So this nature will help you a lot while tackling the properties. And for this cosec theta and sec theta, earlier I gave it to you. Like earlier, see, I wrote it when I took this graph. So please include those things. And these are very, this is the nature of curve in principal branch. Nature of curves in principal branches. In principal branches. Because this nature will help you a lot. So I end up here because time has shot up. I really wanted to cut it well within 1 hour. So thank you. With the hope and expectation that next time you will come adequately prepared so that comprehending the properties of inverse function comes handy to you. Thank you.